Monomial factors and GCF, greatest common factor. So let's start off by reviewing, simplify using the distributive property and combining like terms if possible. Pause the video here and see if you can use the distributive property and simplify. All right, so if we distribute 0.5 times x, we get 0.5x, and 0.5 times 4, or half of 4, will give us 2. Combine like terms. 2 and 8 are like terms, will combine to give us positive 10. And we can't add 0.5x and 10 together because they are not like terms. Remember, to add or subtract, we need like terms. We don't need like terms to multiply or divide, but we do need like terms to add or subtract. All right, the other warm-up problem, 5 times 2x is 10x, and 5 times 3y is 15y. Bring down 0.4y. Then we're looking for like terms. Which of these are alike? 15y and 0.4y are alike. They combine to be 15.4y. And we cannot add the 10x and 15.4y together. They are not like terms. So that's what distributive property looks like. What about finding area? How do I find the area of a rectangle? Length times width. So we have 8 times x plus 5.1. And I can distribute again. 8 times x, 8x. 8 times 5.1, 40.8. And they do not combine, so my final answer for area of this rectangle is simply 8x plus 40.8, or 40 and 8/10. What are the factors of 4? So we're talking about greatest common factor. We're not talking about multiples like counting by 4s, 4, 8, 12. We're talking about common factors, numbers that multiply to give us 4. So I know right away in my head, 1 times 4 is 4, 2 times 2 is 4. So all the factors of 4 are 1, 2, and 4. What are all the factors of 8? All the numbers that multiply to 8, well, 1 times 8, 2 times 4. So our factors of 8, 1, 2, 4, 8. Then we can look for greatest common factor. So we're looking for not only the largest number, we're looking for the largest common number, and the largest common number that is a factor. So the largest number on both of these lists is 4. So the GCF would be 4. Well, let's involve some variables. How about 6xy squared? Factors of 6xy squared. 1, 2, 3, 6, x, y, and y. So that y squared, its factors are y and y, and x has just a factor of x. What are all the factors of 8xy? Well, I have 1 and 8, 2 and 4, and then I have my variables x and y. Now, looking for the greatest common factor, I'm looking for the largest number part, coefficient part on both lists is 2. And then I'm looking for the largest amount of variable that they have in common. Well, they both have an x in common, just one x, so we can say that the x part will be 1x. And they both have a y in common, so my GCF is simply going to be 2xy. The largest amount of the number they have in common, the largest amount of each variable they have in common. Notice how it's not y squared, because the second one doesn't have an additional y. They have one y in common. So don't forget about the c part of GCF. They have to be in common. Find the GCF is 6m to the 4th, 9m squared, 12m to the 5th. Factors is 6m to the 4th, 1, 2, 3, 6, m, and m, and m, and m. And 9m squared, 1, 3, 9, m, m. And 12m to the 5th, 1, 2, 3, 4, 6, 12, m, 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 m. So then we're looking for the largest number in common. Well, the largest number in common in all 3 rows is 3. And then how much m do they all have in common? Well, this one has 4 m's, this one has 2, this one has 5. But in common, there are 2 m's in common, m and m. So my GCF is going to be 3m squared. Find the GCF of 5x and 15. 5x has factors of 1, 5, and x. 15 has factors of 1, 3, 5, and 15. So my GCF would be 5. So a common problem for this would look something like 5x plus 15. And if we pull out the GCF of 5 and pretend for a minute we have a distributive property problem, we're really saying 5 times what number would give me 5x? X. 5 times what number would give me 15? 3. So we're taking an addition problem, changing it to this multiplication, or changing it to look like a distributive property problem, and we can always double check and make sure that it works by using the distributive property. So 5 times x is 5x, and 5 times 3 is 15, so we make sure that we're still equivalent to our original problem. So my answer for these would be 5 times x plus 3, but we could always check with distributive property. How about factor 2x squared plus 6x? Well, the greatest common factor for 2x squared and 6x is 2x. So I'm going to write my 2x on the outside. Then I'm going to make parentheses like I have a distributive property problem. Then I ask myself, 2x times what is 2x squared? X. 2x times what is 6x? 3x. Then I could just check real quick to the side. I can do distributive property. 2x times x is 2x squared, and 2x times 3 is 6x. How about this one? 3abc minus 2a plus 3ab. Well, the number part really only has a 1 in common, but if I look at the variables, they all have a in common. So in this case, I'm just going to use the GCF of the variable a. Then I ask myself, what times a is 3abc? Well, that's 3bc. What times a is negative 2a? Negative 2. And what times a is 3ab? 3b. All right, you guys pause the video, try to factor this one, pull out that GCF. All right, welcome back. Hopefully you figured out the GCF was 2. And then 2 times what is 2x? X. 2 times what is negative 10? Negative 5. And if we just distribute to the side, we can double check. 2 times x is 2x, and 2 times negative 5 is negative 10. So it works. Easy peasy. All right, you guys try this one a little harder. We got some variables here with some exponents. Factor by pulling out the GCF. Pause the video here and come back. All right, so our GCF is 3y squared. They both have a 3 in common, and they have a y squared in common. And 3y squared times what is 3xy squared? X. What times 3y squared is negative 9y squared? Negative 3. And as always, we could check with distributive property, get back the original problem. All right, a little harder here. 10y to the 5th minus 8y to the 4th plus 2y squared. Factor by removing the GCF. Pause the video, come back, see how you did. All right, welcome back. So our GCF, 2y squared. 2y times what is 10y to the 5th? That is 5y to the 3rd. What times 2y squared is negative 8y to the 4th? Negative 4y squared. What times 2y squared is 2y squared? You have to have this positive 1 here. We can't put a 0. We can't leave it blank, because then it would no longer be equivalent to the original problem. So we still need to be able to multiply and get back that original problem. So that plus 1 is important. You have to include that in your answer. What if there's no variable in common and the only number that will divide into each coefficient or each number part is 1? Then we have what's called prime. So occasionally you could just write the word prime. If no number will divide into all of the coefficients and they don't have any variable in common, then we call that prime. You can write the word prime. And that should get you guys going on factoring GCF monomials. OUT spells out.